going to be covering current use of CloudFront and serving media from the edge. Now, a lot of you are developers, and I'll try not to be too high level. I know some of you want to hear the technical details, but we'll try and cover exactly what's going to mean something that you can actually walk away and implement today and actually use CloudFront. So what I'm going to cover is basically the benefits of using our CloudFront content distribution network, how that can help you serve media faster, serve media globally. These are the immediate benefits that you can derive from that. I'm going to go over some of the products behind CloudFront as well, and then I'm going to give you some best practices and some ideas for general storing of media, actually processing the media, and obviously distribution, both static and dynamic content. Okay, so what are we dealing with here really? This is the dream. This is what everyone's trying to do, build some fantastic app or some website, right? And the hope is that once you've built it, people love it, right? Now, what happens when you get success? People show up, right? Fantastic. Now, you've got to be ready for that. You've got to have some way that you're going to actually be able to deal with the tremendous amount of traffic. Now, most of you have been through this experience yourselves by trying to serve one customer, 1,000 customers, 750,000 customers. It doesn't matter, but these are the kind of headaches that we are hearing from our customers, right? Amazon, as we talked about this morning, is a very customer-centric company. We listen to our customers, and these are the headaches they are telling us that they're having to deal with. You will be familiar with some of these things, right? If you've ever set up your own network, set up your own system, the ability for you to scale to handle lots of amounts of traffic, especially when you don't know how much traffic is coming, right? You don't always have an accurate sense of next time there's going to be 10 people, next time there's going to be 100 people. As those numbers increase very dramatically, these are the kind of things you're going to have to deal with, especially with unreliable networks, networks that have different dependencies depending on where the customer is. Even here in India, we've got lots of different ISP providers, and we know that some of them perform better at different times of the day and so on. Everyone experienced that you go to a website sometimes, works fine, and you go back to it a few hours later, and all of a sudden, the performance just isn't there, and you wonder why, right? This is because there's this phenomenon that we talk about called internet weather. It's literally the weather can change all the time. Sometimes they'll do routing that'll take your traffic through a very convoluted path, simply because it's cheaper for them to do so than actually pay the full amount to have your traffic prioritized. And your end customers suffer from this. You might have customers on one ISP or one provider on their mobile phone and other customers on another provider with different experiences. So at the moment, Amazon does not have a connection live from Amazon to every one of our customers. We would love to have that. But we call this the last mile problem, right? How do we provide everything we can to make the network work as far as the Amazon boundary, but after that we rely on various providers to actually provide that content. So you want to build something that's going to build a system to deliver your content with an acceptable latency, good download speed, make sure that the bandwidth is capable. These are all the sort of things that are going on. In addition, the important one down there at the bottom, logs, right? Everyone's trying to track traffic. You're going to hear more from Dr. Vogels later this afternoon about big data and what that means. But any of you that have got even a moderately successful app, you're wanting to track data so that you can actually monitor who your customers are, where they are, what they're buying, when they're buying it. Thursday afternoon, middle-aged women between 35 and 40 in Kansas are your best customer. You want to know that sort of data. And the only way you do that is by accurately collecting all the traffic and all the usage. So if you try and do this all yourself, what we find is a lot of customers meet to this end, right? It's a meltdown. We don't want you to have to go through this. So what I'm going to show you today is a more detailed analysis of how you can use our products to avoid this kind of situation. And that's where we introduce CloudFront, which is our content distribution network. Can I ask, any of you are using Dropbox? Yeah? A whole bunch of you. So you know that's on Amazon. And you know that when they deliver content, that sort of content gets delivered very fast globally. So they are using systems like CloudFront to actually deliver the content, even though it's stored within Amazon. How do they push it out to the edge? Right? A lot of our very successful customers are using CloudFront as a mechanism for this. So let's dive into a little bit of details about what is CloudFront in a nutshell. Basically, CloudFront is a content distribution network, as Santanu just described, using 35 edge locations around the world. Now, I'm not going to go over our whole architecture again, but just so that you understand, those edge locations are controlled by Amazon, but they're not connected directly to Amazon's network. In fact, they're loosely coupled, which means we can push content to them and have the content delivered from those edge locations to the customer. In addition, CloudFront provides a very robust, reliable system to route the traffic depending on the latency of the customer that wants the data. That means that basically when anyone connects to your content, that machine has an IP address, has an address. We will determine where the best edge location is and automatically route the traffic to that best edge location. That's what routing really means, right? So it makes it much more efficient. Of course, there's all the details of scalability and effectiveness and so on, which we'll get into as well. So in terms of technical details, this allows you to serve content, either with HTTP or HTTPS. We allow live streaming now, so it's media streaming as well as static content. And basically, you're going to be able to put anything you have in Amazon services deployed out through Content Delivery Network with CloudFront, okay? So let's go over this a little bit more. We've got the regions, and Anthony did a good job of describing that. We've got the regions around the world. You've got your availability zones, the separate data centers. This is where you're going to run your system. This is where you're going to store your data. But the edge locations then add to that all around the planet, making sure that most customers are covered as close as possible. Now, I joined Amazon 4 years ago, and we had, I think, 7 edge locations. 2.5 years ago, when I moved to Singapore, we had 15 or 16. We're now up to 35. So rest assured, we're on a trajectory to add more and more edge locations all the time. So you will see them popping up every few weeks. Last one, as he's pointed out, was in Madrid, Spain. Before that, Sydney, Australia. And the Australians, every time we got on there, they complained very loudly that we need an edge location. We answered them. So that's just another example of customers telling us, we need to get your content closer to the edge, closer to the customer that's actually going to be using it. So let's go back to the basics and actually explain exactly how a content delivery network works. You're going to start off with your user, whether they're on a mobile phone or an iPad or a PC or whatever it is, and they're going to request a piece of content, request a piece of media. The first thing that we do is receive that call through our DNS service, which is called Route 53, and I'll go into that in a little bit more detail in a bit. But we basically determine where that user is and allocate that call to the appropriate edge location, choosing where they are. So they're sitting in Paris, we're going to go to the Paris location. They're sitting in Sydney, it's going to go to that one. Once that call gets made, the CloudFront edge location, which is listening for the request, says, hey, I don't have this content, right? I don't have the ability to serve this, but I know where the content is because we've registered it with the edge location. So at that point, it says, I don't have it on my system, but I know where to get it. I'm going to go get it from an S3 bucket, which is located wherever it is. You might have created an S3 bucket in Singapore, you might have created one in Tokyo or in the US, but it knows to go and get that content, which it then retrieves from S3 and delivers back to the edge location. All this happens just in a flash, using our network as good as possible because we've got as good a connection back from the edge locations back into the systems and the S3 buckets around the world. Now, when that content gets delivered to the edge location is able to deliver to that requester. Very simple, right? You wouldn't have even noticed that happening because this all happens very, very quickly. But the magic really comes when the second user, he turns to the buddy next to him on the office and he says, hey, look at this great video, watch this. When the second person clicks on it, the second request again goes to the same edge location, but this time the edge location says, someone asked for this just a few minutes ago. And guess what? I already have it with me. So I don't need to go all the way back to S3 to go pick it up. I've got it. I can serve it straight away to the customer. So the second person and the third and the fourth and the 100,000 people around him, all going to get a much better user experience. Now, any of you that have downloaded big websites with lots of Chrome, you know what I mean by Chrome, the CSS file, the JavaScript, JPEGs, all that sort of thing around it, it's so much more pleasant if that just fills in very quickly, right? No one wants to wait around a couple minutes for the gaps to be filled in. So this is exactly what CloudFront does. It accelerates the delivery of all the small static components directly to the user. The more people that use it, the better it gets for everyone. That's the kind of delivery we're dealing with here. Okay. The magic of CloudFront is that we can deliver this globally right away to any of you. So if any of you have actually got a desire to make your system global, and who wouldn't, what? You want to make your application readily available to the entire planet. And you can do that simply by starting a distribution in CloudFront, and we immediately advertise the fact that that content is available to all 35 edge locations. So, good example here. You're sitting in Singapore, you've got your content there, and you want to deliver it globally. So you advertise to CloudFront that this content is available. Once that's done, the first request from each of these locations around the world comes back to the server in Singapore to say, hey, I want your web page. That's a dynamic call for an HTML page. The HTML page is then referencing a CSS file, JPEGs, JavaScript, etc. All of that static content is delivered through CloudFront at the local edge location, right from where that user is. So the user experience is so much better for everyone, and it distributes it globally. And this is really empowering if you think about it, because any one of you could be writing an application that goes global right away. You don't have to negotiate anything with any of these edge locations around the world. They're all just switched on immediately. The best part about this from a money point of view is you only pay for what gets delivered. Now, we all want you to have a huge successful application like the one we saw with thousands of users, but what happens if no one shows up and you don't have any users at all? We won't charge you a cent because we only charge you when a piece of content is requested and delivered. Okay? If a 100 meg video file is made available on CloudFront, but the user only downloads 10 meg and then stops, we'll only charge you for that 10 meg. So it's a very efficient pay-as-you-go model. And it makes sense that you wouldn't go to another provider and say, I want to buy X amount of terabytes of data transfer for the next 6 months, when you're not sure if even the customers will show up. Very, very efficient model there. So we basically take care of everything you need to set this distribution up worldwide. Okay? In terms of how this actually happens, those of you that are familiar with the management console will recognize this, but it's simply a matter of going into the dialog. You can accept the defaults if you want, but you throw up the system to actually point up at the origin source. Now, a little bit of flexibility we offer here as well. If you want to store your content in someone else's storage system, or you have a server at home that has the content on it, that's fine. We can get CloudFront to point of that as the origin server. We would prefer and recommend that you actually put all your content in Amazon so that we can point to that as the origin source, but it's up to you. You just decide where you want that origin source to come from. Okay, once you've done that, we're going to go to the next step, which is setting up the special request details. Is it HTTP, HTTPS? You can mask the URL at the top with your particular CNAME. Let's say it's kingsley.com, and you want that to show up instead of CloudFront's details. But we'll basically give you a URL prefix that points to all the edge locations around the world. If those of you that know how IP addresses work, this is called a CNAME, not a specific IP number. The reason for that is that CNAME is registered globally with the domain name system that can actually deliver the correct IP address for each specific edge location. And that gives us the flexibility of actually changing it around to make sure that we allocate you to the appropriate edge location. All right, there's another term that I want to draw your attention to here in the middle of the page here. I hope you can read it at the back. Ttl, Time To Live. This is a very important concept. When you put a piece of content out on the web, you basically define how long it'll be before it expires. Now, if it's your logo of your company, chances are it'll probably stay the same for the next 2 or 3 years, so there's no need to change it, right? If you're a news site, and this is the front page, and the picture on the front page, you want that TTL to be very low, maybe 10 seconds or 15 seconds, because the news could change every 5 minutes. If you're covering a cricket match, for instance, and there's a picture of the last ball bowled, you don't want that ball to stay on the screen for long, because the next one that comes along might be a 6, and you want to change the news very rapidly, right? So basically, you're telling the system how long between the time that I get the content and the time that someone else asks for it, do I just keep using the same content or refresh the request? Remember back a few slides when we went back to S3 to get the original content from the origin source? That's exactly what I'm talking about. So if the TTL is about a minute, people download it for a minute, and then it says, okay, at this point, it's probably expired. Let's go back and check if there's an update or a refresh. That's the concept of TTL. And you can define even down to 0 TTL, which basically means every time someone asks, if it's not immediately exactly the same request, go back and check for the origin. All right. The second aspect of this that I just want to go into is the ability, again, flexibly allowing you to change the pricing model. Now, some of you might not know this as a fact, but one of our most expensive costs inside of Amazon is the power, right? To actually run all these data centers costs a lot of energy. So that energy, because it's priced differently around the world, means that our data centers deliver compute, storage, database, and network at different prices around the planet. So some of the edge locations serve content or serve gigabytes data transfer at different prices. It's more expensive, for instance, in Brazil than it is in the west coast of the US. We offer you the opportunity to actually decide if you want to exclude certain price zones. Okay? We call them a price class. So if you want all your content only served out of the cheapest edge locations, that's fine. It won't be as good an edge location distribution, but it'll cost you a lot less. If you're willing to pay for it, we suggest you go right up to the optimal service, which is basically use whatever edge location is closest to the user. So if you do have a user in Argentina, for instance, they'll pull the data from the edge location closest to them, even though it might be expensive. All right, these are the kind of concepts that you set up. You'll notice logging is there. You can leave all this as default, and just with a few clicks, you can distribute it. But basically, at the end of that process, you've told CloudFront to look out for or listen to this content and be ready to receive requests for it. Having done that, we also use something called Route 53, which is our DNS service, which as well will use the edge locations around the world to actually route the traffic most efficiently. So if you have a domain like kingsley.com that you want to actually register with us, you can change the name servers to use our edge locations, CloudFront's edge locations, to spread the DNS information. This gives you an amazing amount of flexibility. You can put subdomains like www or media dot or whatever and have those updates done globally very, very rapidly. All right, the next major advance, everything I've been talking about up to now, media, static content, CSS, JPEGs, is actually this concept of dynamic content. Now consider this. If a request is made to a web server, and that web server has to process it, and think about it, and returns a result, why should you make that server do the same request again 5 minutes later when it's exactly the same request? So we come across this ability for us to cache a dynamic request, a dynamic call. So for instance, a very simple PHP file that looks in a database, gets the latest result, processes it, and returns the result. Why repeat that again on the server when we already have the content? So if you have 1,000 customers asking for the same dynamic content, CloudFront can actually cache the result at the edge. Again, much better user experience, much better, much improved system and service and reliability in the time that the actual app will actually return the request that's made. So if you look at this, how we're doing this is we actually keep the connection open between the edge location and the server in question. If you have an EC2 machine, a compute system somewhere in the world, we will open that connection and then keep it up for some certain amount of time, which means we don't have to go through the whole process of doing the handshake every single time. Make sense? So you can efficiently keep the connection open and service a bunch of customers with the same dynamic request. When you put all this together, this is basically how it looks. The users, wherever they're defined, are going to put in the request. The static content gets routed through edge locations to a request to S3 where the bucket, the origin is. If it's already in the edge location, it serves it. And then if it's a dynamic call, for instance, all your PHP files, it's going to route that to the specific load balancer or the EC2 machines that are actually running it. Now, I know I'm throwing a lot of TLAs, three-letter acronyms, and alphabet soup at you, but I just want you to understand basically what are all these services behind the scenes, behind CloudFront. On the first time, there's S3. That's your origin source. That's just your massive storage, right? Just think of it as a big bucket where you can put all the storage in. Every system needs a database of some kind. So we recommend Relational Database Service, RDS, right? Where you can run MySQL, Oracle, SQL Server, etc. That might hold the index or the system that you actually use to look up the media that indexes all the content in S3. One of our newest services, DynamoDB, perfect for very rapid lookups. If you're doing a lot of chatter between your EC2 instances and looking up the index of the media content, this is perfect for that. Then obviously you've got your EC2, which is your compute power. And if you come to one of the other talks, we're going to talk about the elasticity of the system and how you use load balancers and auto-scaling to actually handle increased traffic for the dynamic content. So when you put it all together, this is how it looks. You've got the system which is fronted by CloudFront, and all the system behind it can actually handle the media. I know you can't probably see this in much detail, but if you go to aws.amazon.com/architecture, we have about 10 or 15 of these sample architectures online, which are really great diagrams to study. If you take a look at them and really get into the details, you'll see that these are how successful companies have built systems that leverage all of our components together to actually deliver their content. And of course, we're helping companies to deliver in a whole bunch of different formats. You might want to target iOS formats or Android or websites and so on. There's a lot of success on that. Some of our customers tell us that CloudFront really works for them because we take the headache and the strain off of them in terms of setting up these distributions. There's a huge amount of work that goes into actually setting all these up. But once Amazon's done it for a global distribution, something like Amazon.com uses this system as well because we leverage AWS for Amazon.com. So we have to be able to spread that shopping site worldwide, right? We can leverage that same system for you, the customer. And whether you're serving pictures of your family to a couple of friends around the world, or you've got a super successful website, or in cases like InMobi where they want to distribute advertising around the planet, that's the kind of system that we're looking to use. We've got really cool customers like PBS that have actually got staggering amounts of data that distributes through CloudFront. These guys alone are doing 1 petabyte per month through CloudFront. It's fantastic. Again, they're only paying for what they use, and they're using a lot, but they're servicing a ton of customers through that. One of our most successful fun stories recently was the whole NASA, the Curiosity landing. Now, it was really important for them to be able to scale up and handle the influx of requests at the moment the Curiosity landed. if you were like me, I was watching with bated breath as we were hearing on the news whether it landed successfully, and everyone wanted to get one image on their machine, on their device, and that was this one, the first image taken from Mars by Curiosity. Now, think of the demand and the spike of the traffic as those requests came in all at the same time. CloudFront was able to scale up and handle the distribution of traffic around the planet as everyone made the same request. And because it was cached at each of the edge locations, it wasn't hitting a server back home very, very heavily, right? So I'm going to try and explain how these companies have done this successfully and what you can do to implement right today to actually save money and actually get a better performance. The first thing I'm going to recommend to you is to offload all the static content you possibly can into CloudFront and S3. Now, what do I mean by offload? If you've got a device, a server, that's serving out JPEGs and CSS files, it's having to work hard. The request comes in, it processes it, finds it on the local drive or the local memory, and then sends it out. If you can take that content and put it in an S3 bucket, fronted by CloudFront, so that the requests made by the user hit the CloudFront service and not your system, what do you immediately do? You can shut down half of your servers. There's no need to be running tons and tons of servers when you've got much less traffic on them. So what we encourage you to do is take a look at the CPU load on your machines. Move some of the static content over to S3 and CloudFront, and you'll realize that the CPU load on those machines, even serving the same amount of traffic, will go down. Now, CloudFront should not be thought of as a single machine. It's not. It's a service. So we have thousands of machines able to serve thousands of customers all at the same time. One or two customers often ask me, so if I've got a very busy site, how is Amazon going to be able to handle my traffic? And the answer is that we have hundreds and thousands of customers. Everyone's got their own different spiky load, right? We've got companies that sell flowers online. Now, February 14th is a very busy time for them. You can imagine in the US, it's a big spike and everyone's ordering. February 15th, very, very quiet. So their graph or their spike ramps up to February 14th and then goes down. Another company might have a payroll reporting system that on the 26th of every month spikes up and then spikes down. The point I'm trying to get at is if you take all of these patterns, all of these traffic patterns, and you step back and you add thousands of them together, Amazon has the advantage and the scale of being able to see a huge amount of traffic that we can deal with on a very scalable way. So individual customers' needs are actually met through the addressing of that huge amount of traffic. Okay? Makes sense? The second thing that you can do is to, as we talked about just now, move this dynamic content through CloudFront. And what that means is pointing your entire website through CloudFront gives us the opportunity of looking for repeatable cached requests, repeatable cached dynamic requests, and redirecting them through CloudFront. Again, if it's not hitting the server as frequently or as much, that probably means that you can use a smaller instance. Those of you that are familiar with EC2 might have your website or your web server running on quadruple extra larges, big machines. Now, if we can suddenly do this kind of thing with CloudFront, you can reduce those same machines down to smalls, right? You're just going to run less machines, less hard. It's going to be huge pocket savings, right? Massive reliability there. All right, the next thing I just want to repeat from a best practice point of view is this don't repeat yourself concept of media storage. A lot of you will be storing very large files. Everyone's getting increasingly addicted to media and videos and JPEGs and so on. If you can take a video like this, which is stored in high definition, it's probably going to be a very big file, and you can store that once, but all the derivative works that come from that, in other words, the reformatted, transcoded versions for Xbox, for iPhone, for iPad, and so on, all of those derivative works on the right can actually be derived from the left one. So why store all the ones on the right at full price? Now, we offer something in S3 called RRS, Reduced Redundancy Storage. We will trim 1/3 off the price immediately just by setting the flag to RRS. Now, what are you actually doing when we do that? Everyone's heard about S3 and how powerful it is and the 11 nines of durability that we offer. That's a very expensive for us programmatically to actually make sure we've got enough copies to ensure 11 nines of durability. When you go to RRS, we drop that down to 4 nines of durability, 99.99. And I hesitate to use the word only, because if you think about only 4 nines, 4 nines actually represents 400 times more reliable than a standalone hard drive. If that's good enough for your derived works, we will trim off 1/3 of your price on the S3 storage. So if you've got tons and tons of media, and some of our companies got 35, 50,000 titles, movies, each one taking a lot of gigabytes of storage. So we encourage you to think about taking the original content, the high-def content, and either storing it in S3 or maybe even the new Glacier, and then creating derivative works and storing that in RRS. And those of you that are familiar with will know how easy this is. It's simply a matter of going to the console and changing S3 content from normal to RRS. Immediate savings on that. There's an added benefit to doing all this. Because the content is stored in one place and one place only, all the distributions to it and all the requests for it come to one place. So your logs and tracking of usage of that media becomes much more accurate. If you've got multiple copies around your system, every single request to it has to be aggregated so that you can collect all the logs and analyze them later. But if it's all in one place, you have the benefit of getting that all there. Okay, finally, I'm just going to talk about using Route 53. Route 53 enables you to host your DNS host zones, and we encourage you to take a look at this. It's really inexpensive. I think it's 50 cents per month per zone for your first 100 zones or something. But take a look at how this can actually help you to distribute the content about your DNS zone, the content about your domain, using CloudFront's edge location service. If we use our edge locations, 35 and counting, we can distribute the knowledge of your DNS zone much, much quicker to users. I remember when I started playing around with the internet, I made a request for a domain, and it took something like 2 months for me to get a letter back in the mail that said, you've been approved for such and such a domain. And then I was able to register it and wait another few weeks for it to go live. All of this happens now within a matter of minutes. You can register at www.kingsley.com and immediately point it towards your application using the Route 53 system. In addition, we can now globally load balance, which means we can distribute the dynamic requests for your content, your application, to multiple regions around the world. What this means is that you can actually run your same application all over the planet in our different regions and actually have the service automatically bounce the traffic depending on where the latency is. So no longer do you have to spend a lot of money on some of these very expensive DNS, global load balancing or global latency systems. So in summary, think of CloudFront as just the big front to your application, the big front to your application that you can then serve all your content through. Behind the scenes, you've got your elastic load balancing, your EC2, your compute, your storage, etc., etc. But think of CloudFront as a way that you can rapidly deploy your content, improve your user experience, and more importantly, drop your prices and at the same time get more efficiency out of your system. So I hope that was useful and gave you some tips and tricks. I'm now going to hand back to Shantanu, and maybe we've got some time for questions. Let's actually take any questions in the audience. Yeah, I think we've got 3 T-shirts for the first 3 questions.
Yeah, is it possible to use my own DNS service, or do I have to use Route 53?
The question is, can you use your own DNS service? Do you have to use Route 53? Absolutely, you can use your own DNS service. If you,
but can I use CloudFront along with that?
Yes, you can. Exactly. No problem. So CloudFront and Route 53 are independent. Route 53 just uses CloudFront to actually distribute the DNS information. So if you've got your own DNS service, that's fine. All you use for CloudFront is you get a prefix. It's a code.cloudfront.net, and you put that in front of all your content. And that's the DNS that gets registered with your DNS and tells wherever the request comes from, we will then send the traffic back. Yeah?
Hi.
Second one, go ahead.
If I have a website and I want to invalidate the cache every week, what kind of flexibility is there?
Sure, good question. So you ask, how can we invalidate the cache? And for those that you don't know, invalidation means I just sent a picture out or the news out or whatever, but I want to take it off. I don't want people to download it. So you make either a programmatic request, you can write an API call to invalidate a piece or an object, or you can actually invalidate it through the console. You can go into the console and say, this JPEG, which is the front page of my news, is no longer valid. Now, it's not immediate, let me warn you. It takes a little bit of time for us to communicate with all the edge locations and tell them, hey, you know that piece of content? It's no longer current, take it off, right? There's an additional solution I'll offer you if you use this. In your HTML file, if you reference the front page main picture as mainpicture.1.jpg, and that goes out on CloudFront, all you have to do is update your HTML file to reference mainpicture.2.jpg, and then distribute picture.2.jpg out to the world, so that every subsequent dynamic request for the HTML page will now point to the new picture, or the 3rd version, or the 4th version. And in that way, you can actually move versions very quickly without having to go and invalidate the content as well. So that's one more solution. One at the back there, go ahead. All right. Yes? So the data doesn't change at all. All we do is keep less copies, less numbers of copies in the system. So if you've got 10 gigabytes of storage in S3 and you change it to RRS, that same content is exactly the same. The URL which references it exactly the same. The only thing that changes is the size of your bill at the end of the month. So it immediately reduces that. Now, when you put data in, if you're doing it programmatically, you can opt for the RRS option immediately, rather than putting it into S3 and then changing it to RRS. And if you feel a piece of content is especially valuable and needs to be kept in the full 11 nines of durability, you can always change it back. So it's pretty simple. What's that? The performance is exactly the same. You won't notice the difference. It's just a matter of how many duplicates we keep in the system. Remember as well that S3 isn't one single box where we keep your data. It's actually split up in amongst a whole bunch of availability zones as a service. So we're able to serve like that. But we recommend that you don't point to the actual item inside of S3, because then you're expecting S3 to serve up the content. And if you suddenly get popular and someone in France and someone in Miami is all trying to access it and they're all pulling from S3, that's a lot of traffic back and forth. So the recommendation is simply put CloudFront in front, right? So that it takes all the calls, it caches all the requests, and it uses S3 as the origin source. The demand on S3 is less, and the performance for your users is better. Yeah?
Hi, Kingsley.
One more question, go ahead.
Yeah. So why do you have another DNS service that you're offering? I mean, using the Amazon DNS service, does it have additional benefits?
Yeah, the benefits is that we control it inside, right? I don't know how many of you have used some of the public DNS services. They can take some time to update. We pride ourselves on the fact that because it's leveraging CloudFront's edge locations, we can send those updates in very, very quick time. So we can control the references very, very quickly. Of course, it's also then under Amazon's control from a security point of view. And this is very important. Everyone's heard about hacking of the DNSs and so on. If we put those DNS servers inside of Amazon's boundary, at least we can benefit from all the security that we've invested a huge amount in. And it's really inexpensive. It's 50 cents per month for a domain. And you can put a whole bunch of records on there. Not only can you put globally load balanced records, you can put CNAMEs and text message. You can move the mail servers as well, the MS records, MX records as well. Yeah.
Hi, Kingsley.
Hi.
Hi.
Go ahead.
Yeah.
Yeah, actually, we are a video streaming company, and we have already implemented all the services which you just explained. But my question is, will there be if not a data center, at least an edge location either in India or the Middle East?
Great question. So will there be edge locations in India? Well, I can't give you any dates and times, and we don't pre-disclose any of the announcements, but I will tell you that if you look at the trajectory and how often we add them, it's not going to be long. We're going to be adding more edge locations worldwide as we go along. So all I can say is stay tuned. We're not giving out any specific dates and times, but we hear from the customers, and every time I come to India, I get the same question, definitely hearing it. If you want to try something out, though, let me give you a recommendation. If any of you want to go to cloudping.info, from your location here in India, it'll actually give you a latency check to all of our regions. There's another website called Cloud-Elay, Cloud, E-L-A-Y. And what that does is it hits all the edge locations, all the CloudFront edge locations. And it's very nice in that it gives you a map and it shows you where the closest edge locations are. Now, it could be within India that some of your customers will hit Hong Kong, some of them will hit Tokyo, some of them will hit Singapore, depending on where their routing is, and as I talked about the internet weather. But if you still find that those latencies are inadequate for your needs, for your servers, of your end customers, let us know. But the real magic of this is that your end customers might be on the other side of the planet, and you're able to distribute that application and that content from India or from China or from Singapore, wherever you are, to every other person on the planet just by using that content. So I'm going to end it at that. Thank you very much for your attention, and I'm going to welcome Shantanu back up for security. Thank you very much.